Hi, my name is Chris. Welcome to my channel. Today we're doing valid perfect square, problem 367, Leetcode in JavaScript. Okay, this is considered an easy problem. It says, given a positive integer num, return true if num is a perfect square or false otherwise. A perfect square is an integer that is a square of an integer, and otherwise it is a product of some integer with itself. You must not use any built-in library functions such as square root. Okay. So we look at these two examples. Num is 16. That's true because 4 times 4 is 16. Num is 14. It's false because 3.742 times 3.742 is 14, and 3.742 is not an integer. So the square root cannot be a decimal, basically. Okay, there is a really tricky portion to this problem, and this is the constraints. So num can be a very, very high number. Okay. So what I'm going to do is I'm going to solve this in two different ways. And you'll see why I'm going to do that in a second. But it has to do with this constraint. So let's move over to CodePen. Grab this variable here and define our variable. Oops. And let's create a function. We'll just call it func. For now, we're going to return false. And let's log into the console so we can see what we're doing. Func. Cool. Got false. That's what we want to see. Okay. So a really simple way of doing this would be just to set up a for loop. Say for let I equal 1, because our num is never going to be less than 1, right? And we're going to say if I is less than num, we increment it. And then we say, basically, we're just going to, well, let's do this first. Console.log. I. Cool. So now we're counting up to 16, right? And so now what we can do is we can just say if I times I equals num, we're just going to return true. If it never does, we return false. So we say if I times I equals num, we simply return true. And there we get a correct result. So let's grab this. Let's move on over to Leetcode. Let's try this out. Let's format our code. Now we're going to run the tests, and it's going to pass the tests because they're really small numbers, right? But now let's go ahead and submit it. So we're moving really slow. Okay, first problem. If num equals 1, right. So we need to do here, say equals, right? Well, actually, before we do that, let's just see what's happening here. So because num is 1, it never goes in this for loop, right? So what we need to do is add the equal sign. Cool. Let's go back over Leetcode. We're going add that equals. We should be in business. If you notice, this is moving very slow, and it's not because of my internet connection. Okay, cool. So now we have this problem here, right? So now we have this ridiculously high number. Okay, so I'm going to copy that. We're going to comment that out for a second, and then we're going to paste this here. Okay. So what we could do is we could say, we could divide this in half, right? So we could divide this in half, divide it by 2. Now that's going to be a problem, and it's going to work. It's going to be slow. Should work. Or are we going to get an infinite loop? No, we got it. Cool. But you see it was really slow. But now the issue is going to be if we put 1 back in here, you get false, which is not what we want, because it's saying num divided by 2, right? So what we need to do here is add +1. And now we're good. So let's go back and grab this number again. And hopefully we don't create an infinite loop. I don't think we will. Let me just grab all this. Go back to Leetcode. Let's copy. Paste it in. Let's format it. Submit. I think we should be good. It's going to be really slow. Okay. This is what I wanted to see. All right, so that passed. That works, right? But this is going to runtime. That's ridiculously slow. We're only beating 5.98%. So there's a way we could do this that is going to drastically speed up our code. So I'm going to come back over to CodePen. And what I'm going to do this time is I'm going to take a larger variable that we know is a square root, right? 100. And that's true because 10 times 10 is 100. Okay. Now we're going to get rid of this for loop. And what we're going to do is we're going to split this in half. We're going to start at the midway point, right? So we're going to check if 50 times 50 is if that's 100, then we just return true, right? If it's not, then we split 50 in half and check that. 25 by 25 is 100. If it's not, we split that in half. And then we just keep going. Now, how do we do this? So what we're going to do is we're going to create 2 variables. Low, set it with the keyword let. So let low. It's going to start at 1, and then let high equal num. And then we can create a while loop. Say while low is less than or equal to high. We're going to run some code. So here we're going to define that midpoint. So we're going to say let mid equal math.floor. That's going to help us deal with odd numbers. So low plus high divided by 2. Okay. So low plus high, so that's right now that's going to be 101 divided by 2, that's going to be, what, 50.5, and then math.floor rounds it down to 50. So we're able to check 50. Okay. So obviously that's not the result, and that would create an infinite loop because this condition would never be met. So in order to account for that condition, well, actually, hold on. First we need to say if mid times mid equals num, we return true, right? So if 50 times 50 equals num, we return true. It doesn't. Okay, so now we need to deal with this. We need to split it in half again. So we can say else if mid times mid is less than num, we can reassign low. So we can say low is now mid plus 1, right? If it's greater, which is the only other option, we reassign high. We say high equals mid minus 1. Okay? So, what I'm going to do here before I run the code is, this is really going to help us see what's happening here. So I'm going to console.log low, high, mid. Okay, and then let's comment this so you see what's happening. Okay, beautiful. So we get true. Okay, so now as opposed to counting up to 10, right? You know, having 10 executions of this while loop, we only have 1, 2, 3, 4, 5, 6, right? So a big improvement in the times that we run this loop. And you can imagine we could even, well, let's just explain this first, and then we're going to grab that crazy number and we'll see what that does. But okay, so we start off, low is 1, high is 100. That's going to give us a midpoint of 50 because we got low plus high divided by 2, rounded down, right? So obviously 50 times 50 does not equal 100. So the next pass, right, our new high is going to be 49, right? Because we said a high equals mid minus 1. So then we have 49 plus 1 equals 50 divided by 2 gives us 25, right? 25 times 25 does not equal 100. So through the next pass, or we redefine, again, it's higher than num, so we redefine high is mid minus 1, so now it's 49. So then our next pass is going to give us a new midpoint of 12, right? 12 times 12 does not equal 100. It's greater than 100. So we reassign high to be this midpoint minus 1. So now we have 1 and 11. We divide that in half. It's 6. 6 times 6 is 36. Okay, now, so that's less than. That's going to be less than num. So that means we reassign low, right? So mid plus 1, so 6 plus 1 is 7. So now we 7 and 11. Hold on. So here we're going to have 7 and 11. Oh, right. Okay. Sorry, a little brain fart. So that's going to be 18 divided by 2. That gives us 9. right? So 9 times 9 is 81. That's less than 100. So we go ahead and reassign low to be mid plus 1, which now we're going to get 10. So then this next pass, we're going to have low plus high divided by 2. 21 divided by 2, rounded down, is 10. Finally, we get 10 times 10 equals true. Okay? That's how this is working. So let's go back here. Whoops, I forgot to reset this. Oh, wait, it's not what I... Oh, crap. Hold on, let me see. Well, dang, we can't grab that number. That's okay. Let's just go ahead and grab all this code. I wonder if I can remember what that number is. I don't know, something like this. Yeah, I think that's what it was. It doesn't really matter. I just want to show you the fact that obviously if we're counting on up to like the midway point of this, right? If we were using the previous solution, that for loop, right, there would be whatever half this number is console logs. Now we only have 1, 2, 3, 4, like 20 console logs, right? So this is drastically improving our runtime. So we can get rid of that. Let's grab all this code and oops, let's pull this over to Leetcode. Let's format our code. Let's submit. There you go. It passed, and it's 0 milliseconds. Beats 100%. So much better solution. All right, hopefully you found this video helpful and enjoyable. If you did, please like it. If you'd like to see more like these, please like and subscribe to my channel. We'll see you again real soon.